Okay, so 5.3 notes. Again, you are going to want to have your unit circle out. Okay, it's going to be very important for you as you're doing this. Now, 5.3 notes, I didn't give it a title, but what do you notice about number 1 here? It says name all 6 trigonometric functions. Well, we've only learned about 3, right? We've learned about sine, right? We've learned about cosine, and we've learned about tangent. Yes? And we know sine is abbreviated sin, right? But we don't say sin, we say sine. Usually we say sine theta. And cosine we abbreviate as cosine theta. And tangent theta we abbreviate it as tan theta. We good with that? That's only half the story though. There are 3 more trigonometric functions. There is, actually let me get back before I go there. We know that sine of theta is equal to the y value when we're looking at our unit circle. If I ask for the sine of 45 degrees, you would go and find the y value there, right? Well, sine has a reciprocal. It's called cosecant. And cosecant is abbreviated CSC theta. And all it is, if sine of theta is equal to y, cosecant is the reciprocal, also known as 1 over y. So if I know the sine value of an angle, to find the cosecant, I just do the reciprocal. Cosine we know is the x value when we're looking at our unit circle. And the reciprocal of cosine is known as secant, abbreviated SEC. So the secant of theta, again, it's the reciprocal, so it would be known as 1 over x. And then the sixth and last trig ratio, the reciprocal of tangent is known as cotangent, abbreviated COT theta. And tangent, how do we calculate tangent when we do the unit circle? It's sine over cosine, or in other words, y over x. So cotangent being the reciprocal is going to be x over y. Okay? Questions about that yet? Those are 6 things. Now, you do need to know which goes with which. So the way I try and remember it is the S goes with the C over here. Because initially you're going to want to think cosine and cosecant because they both start with a C. But it's backwards. Sine goes with cosecant, cosine goes with secant, and then tangent and cotangent are pretty easy to know that they go together. Okay? So, let's find a couple things. Cosine of negative 180 degrees. If I look at my unit circle, where is negative 180 degrees? Isn't it in the same place as positive 180 degrees? Because it's just half a thing, right? So there's my coordinates. If I'm looking for the cosine, I'm looking for the which coordinate? The x coordinate? Well, what's the x coordinate there? Negative 1. So the cosine of negative 180 is negative 1. Easy enough? Secant of 90 degrees. Well, first off, 90 degrees, I know where that is, right? 90 degrees is right here, so I'm looking at this right here. But let me go back for a minute. Secant is the reciprocal of cosine. So I'm going to start off asking what is the cosine of 90 degrees? Well, 90 degrees, cosine is x, which is 0. To find secant, I just need to do the reciprocal of this. So the secant of 90 degrees would be, this is technically 0 over 1. It would be 1 over 0, which is undefined. Okay, so when you get these new ones, these cosecant, secant, cotangent, find the one that it corresponds with and then just flip it. Easy enough? Good. All right, use the unit circle to find the 6 trigonometric functions for a 135-degree angle. Now I'll get my unit circle in just a minute. When I'm looking for the 6 trig functions, here's what I do. Sine theta equals cosine theta equals tangent theta equals, sine goes with cosecant, secant, and cotangent. I get my answer spaces set up like that. So that way when I find sine, I can just do the reciprocal to find cosecant and continue on from there. So 135-degree angle. On my unit circle, 135 degrees is right here. Do you see these guys? Cosine, sine, tangent right there, yeah? So cosine is negative root 2 over 2. Sine is positive root 2 over 2. And tangent is negative 1. Again, the other way you find tangent is you do y over x, or sine over cosine. Well, if I put this over this, it's the same thing. It's just got a negative, so it would be a negative 1. Now, the easiest one to figure out here is if tangent is negative 1, what's the reciprocal of negative 1? Negative 1, right? Because this is technically negative 1 over 1. Well, if I flip that, I get 1 over negative 1, which is still negative 1. That's my cotangent. What's nice about these two is when I flip them, they're going to be the same over here, right? So I'll do that in just a minute. But something that I notice is one of these is positive and one of these is negative. Whatever is positive, the reciprocal one is also going to be positive. Whatever is negative, the corresponding reciprocal one is also going to be negative. So my secant value is going to be negative, but my cosecant is going to be positive. And we'll talk more about that in number 7. So I need to find the reciprocal of root 2 over 2 so that I can fill in my last 2 blanks. Well, the reciprocal of root 2 over 2 would be 2 over root 2, right? Just by flipping it upside down. But there's a problem. We can't leave a radical in the denominator. So how do I get rid of that radical in the denominator? I'm going to multiply by root 2 over root 2. Do you remember doing that? What does that give me on top? 2 times root 2 is 2 root 2. What's root 2 times root 2? Isn't that root 4? Well, what is the square root of 4? It's just 2. Can I simplify that? Sure can. Those are going to cancel. So the reciprocal of root 2 over 2 actually simplifies to just being root 2. So the reciprocal of root 2 over 2 is root 2. Same thing here. This one's just negative because its reciprocal was also negative. And that would be the 6 trig functions for your 135-degree angle. Any questions there? All right, give me a thumbs up if you're ready to move on. Use your little reactions button on your Zoom. Yeah, I like seeing those. Yes. Like here? We good there? My camera's blocking it. Up here?
Yes, thank you.
Okay. Yes, I heard a question.
Do you have like a PDF of the unit circle?
Yes, good question. Let me show you a PDF of the unit circle. So what I did is I actually, hang on, I have to change my screen sharing options. well, I'll just tell you, you can find it probably just as well as I can. On the home page of Canvas, right next to the notes page, there's a little part where I said you may need the unit circle for this. If you click on the words unit circle, that's the PDF. I attached it right there for you. Okay?
Thank you.
Mm-hmm. Because without the unit circle, this is going to be a lot more brain power. Okay? All right, let's move on to number 5. Find the values of the 6 trig functions for angle theta in standard position if a point with coordinates 5, -12, typo, ignore that M, lies on its terminal side. Okay, so let me think about this for a minute. So I have my axes, right? What quadrant is the point 5, -12 in? 5, -12 is going to be in quadrant 4, isn't it? So what I want to do is I want to think about, I have an angle that's technically, it's either going this way or it's going this way. I'm not so concerned about which direction it's going. I'm really only concerned about where that terminal side is. And that terminal side is here in the 4th quadrant. Okay? Now let me extend this a little bit, make it a little bit bigger for you. Okay? Now, if this is the point 5, -12, if I make this into a right triangle, and this is the point 5, -12, couldn't I label two sides of the triangle, one as +5 and one as technically +12, but I could call that -12, because isn't that the path I took to get to that point? Does that make sense? So using those coordinates, I have two sides of a 3-sided triangle. Well, all triangles are 3-sided. So how could I find that third side? Couldn't I do that? So I have A and B, so 5 squared plus -12 squared equals C squared. So 25 plus 144. What does C squared end up being? 169. What is C? 13, because the square root of 169 is 13. So I can go ahead and label this side 13. So I have a triangle here. We're going to go back to good old Sohcahtoa. Okay? So first off, I need to know where angle theta is. Is angle theta here or here? It's not going to be the right triangle. Theta is always the one that is at the origin. Always, 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 always. That's the whole standard position thing. You always want to pick the one that's up by the origin. So if I know that sine theta, don't we know that sine is opposite over hypotenuse? Opposite is -12. Hypotenuse is 13. That's my sine value. Which means that my cosecant, or the reciprocal of sine, is just going to be that flipped. 13 over -12 or -12/13, doesn't matter where the negative sign is. Does that make sense? Easy? What about the cosine of theta? Back to Sohcahtoa, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. 5 over 13. So what's the reciprocal of cosine? Secant. And that's going to be the reciprocal of 5/13, which is 13/5. Thumbs up if this is making sense to you. Anybody? Okay. And then tangent, we know, is opposite over adjacent. So opposite is -12. Adjacent is 5, so I have -12 over 5. And then the reciprocal of tangent is cotangent. So I just flip this, 5 over negative 12. Again, doesn't matter if you put the negative on the bottom or out front. I will typically put it out front, but just introduce it to show you. There's my 6 functions. Any questions on that one? Because the next one is very similar. Just might get a little more tricky. Maybe. We'll see. Now, one thing I'm hoping that you're noticing from these is some values are positive and some values are negative. And what is it that determines what is positive and what is negative? Well, what determines positives and negatives is where that terminal side lies. This terminal side was in the 4th quadrant, so my x values are positive, my y values are negative. X values are positive, y values are negative. And then when I put a negative over a positive, I end up with a negative for tangent. Does that make sense? Another way to think about it is in my unit circle, all of the points here in this first quadrant are a positive number, comma, a positive number, which means that sine is positive because sine is your y value, and cosine is also positive. And then when I do tangent and I do sine over cosine, a positive over a positive means tangent is also positive. What about in the second quadrant? These are not positive positive, they are negative positive. So what does that tell me? Sine is positive, cosine is negative, and what about tangent? Positive over a negative gives me a negative. What about quadrant 3? All of these points are a negative, comma, negative. So that means cosine is negative, sine is negative. What about tangent? A negative over a negative makes a positive. And then finally, the 4th quadrant, we have positive, negative. All of these points are in that positive, negative form. So cosine is positive, sine is negative. What about tangent? Negative over positive means a negative. So, in the first quadrant, see if you can see this. In the first quadrant, everything is positive, right? So I'm actually going to answer question 7 on your notes right here before we go on to the last one. So in the first quadrant, all of our things are positive. Sine, cosine, tangent, secant, cosecant, cotangent, they are all positive. Okay, so all are positive. In the second quadrant, the only thing that is positive is sine. Okay, so sine is the only thing that's positive. Now, when we're talking about the reciprocal functions here, cosecant will always be the same as sine. So when I say that sine is positive, I'm also technically saying cosecant is positive. Okay, what about in quadrant 3? What's the only thing that's positive? Tangent. And then in quadrant 4, the only thing that's positive? Cosine. So, how can you remember which functions are positive in which quadrant? Well, we have this. And I've seen many different ways of memorizing this. A, S, T, C. If you go in quadrant order, some people think all students take calculus or all students talk crap, something like that. But that can help you remember what's positive in what quadrant if you don't have the actual values to see where it's at. Does that make sense? So that's just kind of a shortcut to see what's positive where. All right, suppose theta is an angle in standard position, so just like up here, whose terminal side lies in quadrant 3. This is the important part. If the terminal side lies in quadrant 3, I know that tangent is the only thing that's positive in quadrant 3. So if I set up my answers, I know that sine will be negative, therefore cosecant will also be negative. I know that cosine will be negative, and therefore I know that secant will also be negative, because tangent and therefore cotangent are the only things that are going to be positive. So if I have my answer blank set up and I just go ahead and fill in those negatives, I'm good. Right? So let's draw the picture of what this is going to look like, just like we did up here. So we have a third quadrant terminal side, and it says the sine value is -4/5. So it's something, comma, -4/5. Yeah? We good? So what's the cosecant going to be? Isn't it just the reciprocal of that? So -4/5, that would become -5/4. Yeah? Now let's think about our Sohcahtoa again, what I had written up there. Okay? If I think about this as my theta, and isn't the sine the opposite over the hypotenuse? So I can call the opposite 4 and the hypotenuse 5 if I make a triangle like I did before. That's going to be more helpful than thinking about it this way. Because if I know 4 and 5, I should be able to use Pythagorean theorem to find that other side, right? So a squared plus 4 squared equals 5 squared. A squared plus 16 equals 25. A squared equals 9, so what is A? 3. Now, if I want to fill in my negative signs, this 3 is in a negative direction and 4 is also in a negative direction. So I could figure out my negative signs that way, or I can figure it out the way I did at the beginning using my shortcut there. Okay? So, now let's find cosine. Cosine. Cosine is adjacent over hypotenuse. That would be -3/5. So the reciprocal of cosine, secant, would be -5/3. And then finally tangent is opposite over adjacent. Negative over negative makes a positive. That is 4/3. Therefore cotangent is the reciprocal, 3/4. And that's what I've got. Any questions there? All right. Lost my mouse there. Where'd my mouse go? Okay.